Problem number 5, calculator problem. An airplane's velocity is 580 miles per hour, flying in the direction of a north 35 west. A strong wind begins to blow at 80 miles per hour from the south. First thing we're going to do is draw a diagram, label it, and show all the important information on there. So I am first going to put a point here, and I'm going to show that first bearing I know. I know the plane is traveling in the direction of north 35 west. So I need to open that angle up 35 degrees to the west. I know then that angle right there is 35 degrees. And there, that purple line represents the vector of my airplane's engine velocity. So the direction I'm headed and the velocity from the engine. So I know that is 580. So I will label it as 580 miles per hour. My vectors will be representing the velocities. Okay, what else do we know? We know a strong wind begins to blow at 80 miles per hour from the south. It's blowing from the south to the north. So I'm going to add my vectors, tip to tail, and so I'm going to put the tail of this vector at the tip of my last one. That's how you add vectors. We're adding the wind vector to the plane vector. And what do we know? We know that this vector has a magnitude of 80 miles per hour. And so now if we show the resultant, which is going to be the sum of these two vectors, that pink line right there going from where we started to where we finished. Now, we almost have our triangle set to the point where we can solve it, but we need to figure out what is that angle in order to be able to find that opposite pink side. Now think about the context of the problem. That pink side right there is representing the actual path of the plane. As well, it is also representing the actual velocity of the plane with respect to the ground. So let's call that side C, and let's think real quick about how we can figure out what the angle opposite of C is, because then we can use the law of cosines. Well, remember the only angle we know anything about, that 35 right there. Picture this north-south line continuing down right there. We have a north-south line right here as well, so that angle is alternate interior angles with that angle, which means this angle is 35 degrees as well, which then means I can find angle C as 180 minus 35, which is going to give me 145 degrees. And so I can use the law of cosines and set up my equation as C squared equals the other two sides squared and added together minus 2 times those same other two sides, times the cosine of the angle that I know, 145. And again, remember that angle is opposite of the side we're trying to find. And now we just want to plug all of this in to our calculator. You should find that C is just about 647.161 miles per hour, which represents the side length C there, the magnitude of this resultant. So that would be our answer to part C, 647.161 miles per hour, but we still need to figure out the bearing. So if we're trying to figure out the bearing that this plane is actually headed on, that is asking us for this angle right here. Let's call that theta, because the bearing is going to be measured off of that north line. The pink is showing us where the plane's headed, so we know that whole angle is 35, so we need to find that theta right there. So if we can find this angle inside of the triangle, let's call it angle, it's teeny tiny, let's call that angle alpha right there. We can find that using the law of sines. Side 80 is opposite of angle alpha, and we know the C and the 145. So let's say that the sine of alpha divided by 80 equals the sine of 145 divided by that value C that we just found, 647.161. And I'm going to use the exact value in my calculation and get the exact answer, not round to the very end. And so I need to manipulate this equation to get alpha. To do that, I need to multiply by 80 on both sides and take the inverse sine of both sides to find that alpha equals the sine inverse of, I'll show you how I would type this into the calculator, 80 sine 145, close your parenthesis, over that second answer, the last thing we got, the 647.161. That should show you that alpha. I forgot to write my division right there. You need that. And when you do that, you should get that alpha angle to equal 4.066 with a little bit of rounding. And if that's alpha and we want theta, we know that theta, ooh, that's a bad theta. We know that theta is going to equal that 35-degree angle minus that angle alpha that we just found. And so when you do that, you should find that theta equals 30.934. And so then to state that as a bearing, the bearing has to be north 30.934 west.